Jupiter. Jupiter is the largest and most massive planet in the solar system. Jupiter is 11 Earths across with a diameter of 88,846 miles. By volume, Jupiter reveals itself as the true king of the planets. You could fit every other planet within Jupiter and still have some volume left over. Important facts about Jupiter. Like the Sun, Jupiter is primarily composed of hydrogen and helium elements. Jupiter orbits the Sun at an average distance of 484 million miles. At such a vast distance from the Sun, Jupiter receives very little heat from the Sun. As a result, its upper atmosphere is very cold, having an average temperature of -186 degrees Fahrenheit. However, the interior of Jupiter experiences far higher temperatures that generate vast storms and fast winds. Winds in Jupiter's atmosphere can reach 250 miles per hour. Jupiter's atmosphere is about 5,000 miles thick and consists primarily of hydrogen and small amounts of helium and methane. Beneath these gases is an ocean of hot liquid hydrogen. Jupiter's liquid layer of hydrogen is about 30,000 miles thick. Beneath this, scientists believe there is a layer of water, pneumonia, and a rocky core that would measure around 4,200 miles in diameter. Deep within Jupiter, the pressures reach 45 million times greater than Earth's, and temperatures can go as high as 20,000 degrees Fahrenheit. Although we are generally familiar with hydrogen being a gas, deep within the interior of Jupiter, it takes on a far different form. Under the extreme pressures and temperature within Jupiter, hydrogen turns into a metallic liquid. Like a metal, hydrogen can conduct electricity in this liquid metallic state. A moving electric charge also produces a magnetic field. This sea of liquid hydrogen creates Jupiter's magnetic field, the largest and most powerful of any planet in the solar system. Is Jupiter a failed star? Jupiter and the Sun are made of virtually the same stuff. Both objects are primarily composed of hydrogen and helium, along with trace amounts of various other chemicals and elements. All that separates stars from gas giants like Jupiter is the fact that stars are powered by the process of nuclear fusion, wherein hydrogen nuclei are fused together to form heavier nuclei. Any object that can sustain nuclear fusion for extended periods of time is defined as a star. In order for nuclear fusion to occur, an object must be massive enough and hot enough for individual atoms to overcome the repulsive forces between them. Jupiter is the most massive planet in the solar system, and its interior is thousands of degrees. Is there a chance that Jupiter may be a failed star? Did Jupiter almost become a star? As was stated before, all that separates Jupiter from the Sun is mass and temperature. Theoretically, if Jupiter were to increase its mass by a large enough factor, the hydrogen in its core would undergo nuclear fusion and Jupiter would become a star. However, there is no evidence in our solar system that Jupiter almost became a star. Although Jupiter is often referred to as a failed star, this is not technically true. There simply was not enough material where Jupiter formed for it to grow massive enough to become a star. How massive would Jupiter have to be? Jupiter is the most massive planet in our solar system, yet it is still very far off from becoming a true star. Jupiter may be gigantic, yet even the Sun makes it look tiny. The Sun is over 1,000 times the mass of Jupiter, and so in order to become a star like our Sun, Jupiter would need to increase its mass by a factor of over 1,000. However, the Sun is not among the lowest mass stars in the universe. The lowest mass stars in the universe are red dwarf stars, the smallest of which is only 7.5% the mass of the Sun. If Jupiter were to become a star, it is much closer in mass to a red dwarf than the Sun. Jupiter would need to increase its mass by a factor of around 80 to become a small red dwarf. Interestingly, there is one stellar-type object that Jupiter is much closer in mass to. Brown dwarfs are true failed stars, and they represent the state between a planet and a star. Brown dwarfs are not small enough to be a gas giant, yet they are also not quite massive enough to become a star either. Brown dwarfs range from 15 Jupiter masses to 75 Jupiter masses. Around 80 Jupiter masses is when a brown dwarf becomes a red dwarf. If anything, Jupiter is closer to being a failed brown dwarf than it is a failed star.